Hello friends, I welcome you to my YouTube channel MakePM. So in this video we will solve a numerical problem on welded joints. So in this case this is compound welding, because here you can see parallel welding also, parallel fillet welding also, and here it is transverse fillet welding also. So this is compound welded joint. So let's read the problem. A plate 10 cm wide. So a plate 10 cm wide, B is equal to 10 cm is joined with another plate by a single fillet lap weld and double parallel fillet. So this is double parallel fillet 1 and 2, and this is single fillet lap. Okay, in figure the maximum tensile and shear stresses are 75. So sigma T is equal to 75 Newton per mm square, and tau allowable, maximum allowable tau shear stress is 55 Newton per mm square respectively. Find the length of each parallel fillet if the joint is subjected to a total load of 90,000 Newton. So P is equal to 19,000 Newton. So it is given. We have to find L2, length of parallel fillet welds. So L2 is equal to what? See, everything is in mm, so you can write B is equal to 100 mm, because we have converted it to from centimeter to millimeter. Okay, now you can see that width of this plate is given as 10 centimeter or 100 mm. So it is also equal to this L1. Okay, welding will be equal to length of this plate only, so you can also write it is equal to L1. Okay, now let's derive the formula. One more thing, you can see from the diagram only that if we are applying force in this direction, then this weld, which is of length L1, will be in under tensile stress, and these two L2 length parallel fillet welds will be under shear stress. Okay, so suppose P1 is load taken by this L1 length weld. Okay, and P2 is load taken by L2 parallel welds. Okay, so total load P is equal to 90,000 Newton will be equal to P1 plus P2. Now let's derive the formula. Okay, so if these are two plates, let's draw it bigger so that it will be visible. So if this is one plate and this is another plate and this is fillet weld, this is fillet weld. Okay, so this is S, this is S, this is thickness of the plate S, and this is also leg of the welding, which is also we assume equal to S. Okay, so this length and this length is same. This is 90 degree. So if we draw a perpendicular from here to here, then it will be also 90 degree, it will be also 90 degree. This is 45 degree because these two sides are same, then these two angles will also be same. So this is 45 degree, this is 90, so it will be also 45 degree. Okay, or this is 90 degree, so sum of these two will be 180 degree, and these two are same angle, so 90 divided by 2 is equal to 45 degree. If we draw this triangle here, we can draw it like here, so in zoomed form, so that you can easily see. See, initially this was 90 and this is S, this is S, so this is S, so this angle and this angle will be same because these two sides are same. Okay, so this is 90, so total angle will be 180, so the sum of these two will be 90 and these two are equal, so they will be 45 each. Okay, and this is T, this is throat of the weld. Okay, throat of the weld, so we will write sine 45 degree is equal to, from here perpendicular T divided by hypotenuse S for this triangle. Okay, so T is equal to S sin 45. Sin 45 is equal to 0.707. Okay, so into S it will become equal to T. So this is throat of the weld. So what will be the area of the weld? So throat of the weld is thickness into or width into this length. So length is this length. Okay, so from this drawing we can see we have assumed P1 is equal to load L by taken by L1. So P1 is equal to load taken by L1. So what will be load? P is equal to, this is under tensile load, so sigma T into area of weld, minimum area of weld, because it will fail at the minimum area. So it will be equal to sigma T into length of the weld into width of the weld is T, throat width. So it will be equal to sigma T into L1 into T is 0.707 S. Okay, so it is 0.707 L1 into sigma T is equal to P1. Now if you put the values, 0.707 into L1 is, we have calculated 100 mm, into sigma T is 75 Newton per mm square. So if you will calculate, you will get, let me calculate, you can also calculate 0.707 into 100 into 75. So it will become 5302 Newton. Okay, so this is load taken by this. Sorry, one thing I forgot, sorry for the mistake. P1 was 0.707 into L1 into sigma T into S. We forgot S. So S was thickness of the plate. So what was the thickness of the plate? Thickness of the plate was, see here, 1.2 centimeter. So S was 1.2 centimeter, which is equal to 12 mm. Okay, so we have to multiply by S here, so it will be into 12. So here also it will be into 12. So it will become 63,630 Newton. Similarly, in this case, L2 length of welding, there are two parallel weldings. For them, P2 will be equal to area into shear stress, maximum allowable shear stress, because they are under shear. So it will become area. What will be their area? Area will be throat into length of the weld, L2 into tau. Okay, so throat thickness is 0.707 into S. And now there are two sides, here also, here also. So there will be 2L2. L2 is length of the one fillet, so L2 plus L2, 2L2 into 2 into L2 into tau A. So it will be equal to 1.414 into S into L2 into tau. So we have to find L2. So what is P2? Total load P was, as you see here, 90,000. Out of 90,000, 53,630 is taken by P1. So P2 is P minus P1 is equal to 90,000 minus 63,630. So it will become P2, if you will calculate, $26,370. So 63. So we can write it here. 26,370 is equal to 1.414 into thickness of the plate, what, 12 mm, into L2 we have to find into tau was given, maximum allowable shear stress was 55. So from here you can write L2 is equal to 26370 divided by 1.414 into 12 into 55. So if you will calculate it, you will get 26370 divided by 1.414 divided by 12 divided by 55. So it will be equal to 28.25 mm. So this is length of the parallel fillet weld. Okay, so here we have to weld up to 28.25 and here also 28.25. This length had to be weld minimum, so that you can take this load. Okay, so I hope you understood this value. We have the right formula, so it have taken much time, but you can directly remember this formula. Okay, in this case direct formula for P will be 1.414 into S into L into tau plus 0.707 into S into L into sigma. Okay, you can direct remember this formula, and as these changes transverse or parallel, you can change the formula accordingly. Okay, so I hope you understood this problem. If you have any doubt, then you can ask in the comment section, and if you like this video, then please share and subscribe to our channel. Thank you for watching.